Yo, this is Maximize Happiness of Selected Children, 3075. This is the second problem in the weekly contest. I actually found this problem easier than the first problem, because I think the first problem was just too wordy. I don't know, it kind of tripped me up, even though it was an easy problem. Anyways, we're given an array happiness of length n and a positive integer k. When there are n children standing in a queue, where the ith child has happiness value happiness I, and you want to select k children from these n children's in k turns. In each turn, you select the child which has a happiness value. Um, and when you select a child with the happiness value, the other ones that have not been selected decrease by 1. The values cannot become negative, and it only gets decremented if it's positive. So you have to maximize the sum of happiness values. So essentially, um, we have to select two children from this happiness list. We have to maximize the number of happiness. So obviously we're going to select the largest one, which is 3. These two get decremented by 1, so this goes to 0, and this 2 goes to 1. And then we have to select the other happiness, or k, we have to select 2 k's, right? So then we would select 1. After this one gets decremented, the second iteration we'd select this, which would be the 1. So 3 plus 1, that'd be 4. That's our maximum happiness. Okay. Here, for example, we have k is equal to 2, but when we select 1, these all go to 0, right? So here, for example, right, we select the largest one, which is 5. Yeah, I don't know. This medium felt way easier than the easy one, but again, the problem statement on the easy one was just, I don't know, to me it was kind of confusing. As we're gonna, anyways, we're gonna set something, a variable called, we'll just call this, max happiness. And, first of all, I don't know if our happiness list is always going to be sorted. In these examples, they are, but we don't actually know that. I guess we might from here, but I don't know. I don't think it's explicit, like the ith child has a happiness value, happiness of I. It doesn't necessarily mention that the array is always from least to greatest, so we're just going to sort this. We're going to say reverse true, so we get the largest values first, the smallest values last in the array. We're going to say for ancient happiness. Let's find the difference, right? Because again, they have every value in the array has to get decremented after we select the first one. Well, initially it's going to get decremented by 0, right? So let's make our decrement by 0. And we're going to say if k is less than or equal to 0. Well, actually, k can never be. K is always positive. A positive integer k. Yeah, k is always going to be positive, so we don't have to do less than or equal to. I mean, you can. It really won't make a difference, but I'm going to say if difference is less than or equal to 0, we can break, right? But let's say max happiness is equal plus or equal to the difference. Okay. And then after we add the max happiness, we need to increase the decrement by 1, and the k has to go down by 1. Okay. So that'll be our algorithm. And then we return the happiness. Okay. These are the two conditions that we break out of, and the difference really, again, is this diff, it really is just so we can keep track of how much we need to decrement a specific value in the integer, right? For example, when we select 3, we increment the decrement counter is going to be 1, so we're going to do 2 minus 1, and that's going to be 1. We're going to add that to 3, and we get 4. Okay, that's basically all the diff is doing. It's used to basically account for how much we need to decrement for a specific happiness value. So yeah, I hope that helps. This problem wasn't too bad, I don't think, but if you had trouble with it, I hope this helps.